Okay, we are back in the freezing cold barn. Hope everybody is doing well. Oh, well, another day. So, we started with perimeter, and now we are going to move to area. Okay, so let's get going with area. So, it's important to understand that area is a measure of square units. Okay, so a measure of square units. Now what that means is that we are honestly like squares, like little squares, and we're going to take a shape and we're going to figure out how many little squares would go in it. So we are going to fill a shape with how many squares? Okay. All right, so let's say that we had a rectangle that was 2 feet by 4 feet, just to make things nice and easy. Now let's say we wanted to figure out how many squares we're going to put in here, and the squares we're going to put in are little one by one squares, 1 foot by 1 foot. Okay, so we're going to figure out how many would go in there. So if we start putting in little squares here, you got to give my scale a little bit of a break. Okay, it's not going to be perfect, but there's 1 square. Here's a 2nd square, 3rd square, 4th square, 5th square, 6th square, 7th and 8th. So we figure out that there are 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 square feet. Okay, 8 square feet. So we say that they're squares and we tell them what the units were on that. So we filled this box with 8 square feet. Now the thing to notice is if you look at it and think about it as length and width, in order to find that 8 square feet, could we have just taken 2 and multiplied it by 4? So what ends up is we end up with some formulas for finding this. So that's our first formula. So that's area of a rectangle. So area of a rectangle, again, with just a basic, if we have length and width, area equals length times width. Okie dokie. Then the next one would be the area of a triangle. Okay. And when we look at a triangle, though, we look at it in a little bit different way. So when you're looking at a triangle, you want to make one side lie kind of flat or be on the flat side of the paper. And we're going to call this B for the base. And then the other measurement we need is not these 2 legs, but what we need is the height of your triangle. So the height of the triangle. So you have the base and the height. And when you go to find the area of a triangle, okay, this one is 1/2 base times height. Okay, 1/2 base times height. Now, you might be like, wait a minute, why is it 1/2 base times height? Some of you might not care, but we're in this class because we're supposed to be kind of learning and thinking about these things. So let's look at, I'll try to draw this again. Okay, let's look at a rectangle again. Now, we don't normally call this base and height, but we could call it base and height, couldn't we? Okay, that's flat, and that's the height. So if we look at our rectangle like this, okay, base and height, well, we know the area of the rectangle, so of the rectangle, is base times height. But look what I'm going to, oops, I've got too many pens running around with different colors going on here. Look what I'm going to do. I am going to draw in the diagonal, and now I'm going to look at that red triangle. Now when you look at that red triangle, isn't that half of the rectangle? Okay, so from diagonal to diagonal, or from point to point, so we've got half of a rectangle. So what happens if we want the area of the triangle? Then we're going to take half of what we had above, so 1/2 base times height. Okay, so that is where the formula for the triangle comes from. You take a rectangle, cut it in half on the diagonal, and you have a triangle. All right. Okie dokie. So let's see what we got going on here. So we got 2 formulas to start with. Let's see what they ask us to do. Oh, these are kind of boring problems. All right, how about this one? Okay, so this tells us that this is 3 millimeters and this is 4 millimeters. Okay, and we want to find the shaded region. So find the area of the shaded region. Now, I chose this example because this is the one that's kind of the oddball one. So we've got a triangle going on there, but we have this kind of obtuse triangle. So what ends up happening is we do have a base there, but the height of the triangle, its highest point, isn't actually measured from inside, it's actually measured outside, because here's the highest point. So we get this extra little note here. So this doesn't really exist, it's just there to tell us that this height is equal to 4 millimeters. Okay, so if we want the area, then we're going to take 1/2 the base, which is 3, times the height, which is 4. And again, it doesn't matter which order you do this, so 12 divided by 2, or if you want to cancel first, or however you want to do it. But however you do it, we're going to end up with 6. And then remember that this is square, and we'll be looking at millimeters. Now, the idea is that we're going to fill this with little squares, and apparently there are going to be 6 of them. But in this case, if we start over here, this first square is actually getting kind of cut up, isn't it? So, but this extra space right here might fill in that space right there. So the squares don't have to be perfect squares. You might have to cut them and make them little interesting pieces, but that's what we're looking at there. So we end up with 6 square meters. Okie dokie. Now, the next one we've got is the trapezoid. And the trapezoid is a 4-sided polygon that looks like this. Okay, so these 2 sides are parallel, these 2 sides are not. Okay, so we call this one big B for the big base, and we call this one little b for the little base. And then we're gonna have also a height in here. Now, there doesn't need to be any symmetry or anything, so we cannot make any assumptions about this. These 2 sides are going to be different, and these 2 sides could be different as well. Okay, they could be, one could be shallow, one could be steep. We don't know what's going on. So if we want the area of a trapezoid, and this is what we were given, we'll want to think about how this is going to work. So, what did I do with my red pen? We'll go back to the red pen again. And even though it's not a rectangle, okay, it still has 4 sides, we can turn it into 2 triangles, can't we? So up here is triangle 1, and down here is triangle 2. Now, the area for triangle 1, okay, now it's a triangle, would be 1/2 base times height. So we'll start with the 1/2. But here's the dealio. Triangle 1 up there is upside down, isn't it? So its base is actually this little b, isn't it? So we'll go 1/2 little b times the height, and that height is the height. And then if we want the area of triangle 2, again we're going to go 1/2 The triangle 2 is this big one down here. So its base is big B, and it still has h as a height. So we were able to find the area of the two triangles, but if we want the area of the whole trapezoid, so we want the total area, what are we going to do with these two guys? Right? We're going to add them together, aren't we? So we're going to say 1/2 little bh plus 1/2 big BH. Okay? Now, remembering back to algebra, some algebra skills here. These guys, each piece has some stuff in common, so what we're going to do is pull out what they have in common. So we are going to see 1/2, and we're going to, A equals, we're going to factor out the 1/2 and the h, and if we pull the 1/2 and the h out, here is left little b, and here is left big B. So if you look up the formula for a trapezoid, this is the way you're going to see it. 1/2 height times little b plus big B. Okay? Now, if you want to do it by doing two triangles and finding it that way, that's totally fine. If you just want to go with the formula and use the formula, that's fine as well. The idea is that, you know, when we would be maybe in class or something where I'd tell you to like put stuff away, so I would see if you could come up with the formula yourself. You're sitting at your desk, you have all the formulas right there when you go to take your quiz or your test or whatever. So, you know, it's not as big a deal to memorize the formula here. Okay, but there we go. So let's say that we have a trapezoid. Okay, kind of a weird looking one, but a trapezoid. We're going to say that this is 7 meters, this is 4 meters, and the height is 2 meters. Now again, any way that you want to do this to figure out the answer is totally fine by me, but if we just go with the formula here, we're going to say that the area is going to be 1/2 height, so 1/2 times 2, and then we need to add little b and big B, so 4 plus 7. Now, remember, you got to remember your order of operations here. Okay, let's put those guys together first. So 1/2 times 2 times 11. Everybody agree? So now the 1/2 and the 2 will cancel and just leave us 11, or 22 divided by 2 is 11. But anyway, you look at it, this is going to be 11 square meters. Okay. Let's see what we got next. So when we're dealing with polygons, okay, whether it's a trapezoid or a square or a rectangle or a triangle, the idea is if you don't have a formula, you should be able to cut whatever shape you have into either triangles or rectangles and create a formula. So that's what we did with the trapezoid. We created a formula. So the only one that we can't really do that with then is if we're not dealing with a polygon and we're dealing with a circle. Okay, so we need to look at area of a circle. Okay, so area of a circle. Now, we talked about circumference last time, and we talked about how pi is involved here. So what I want you to do is to start with the circumference, and remember that our circumference is going to be 2 pi r. So remember, all the way around is going to be 2 pi r. Now, I'm going to tell you that the area of a circle is equal to pi r squared. Okay? But how do we come up with that? Okay, how do we come up with that? So I want to show you a neat little trick, and I'll show you here. And because I'm doing this on the board, it doesn't really look all that great. But you can Google this, like area of a circle, and it'll show you like a little YouTube video where it's all nice and drawn out and even has animation and everything. Can't quite do that on the board here. But what I'm gonna do is I am going to cut our circle into, let's see, let's go with 12 pieces. Okay, so 12 pieces, so there's gonna be 3 in between each one like this. Okay, so I gotta work on this a little bit. I'm labeling them different colors on purpose. I know at first you might be like, why are we making like a circus tent here? But that's just the way it is supposed to go. And all of these are supposed to be the same size. Again, you gotta bear with me here. Okay, bear with me. So the idea is that there should be, if you're thinking about it, I'm not gonna draw everything in or color it all in, but there should be, if there are 12 pieces, there should be 6 blues and 6 reds, okay? So what I want you to do is take this circle and we're gonna pull all of the pie pieces out. So we're gonna pull all of these pie pieces out and then I'm gonna rearrange them in a different shape. So I'm gonna take all the red ones first to pull out all the red slices, and I'm gonna line them up so their arcs are touching like this. 1, 2, 3, 4, 5, 6. And then they're gonna look like this. So it's like I'm taking my pizza and instead of having it in the round form, I'm lining up all of the edges so that I have a line of pizza slices. Okay, then I'm gonna do the same thing but from the bottom with the blues. So down here, I'm gonna have 1, 2, 3, 4, 5, 6. Okay, now again, you gotta bear with my scale. I do the best I can. So then we're gonna have 1 piece there, 1 piece there, 1 piece there, 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 and finally there. Okay, so instead of having a round pizza, now we have pulled our pizza apart and we now have it as more like a rectangle. We got that, right? So we end up with a rectangle here. So what I want you to remember is that even in this shape, this measurement here is still R, isn't it? That's still the radius, so that measurement is still R. Then, I also want you to remember that we've got all these little bumps, and if you were to look at all of the little arcs put together, isn't that still the circumference? So all the little arcs, even though they're not in a circle anymore, they still should represent 2 pi r, which means that one side will be half of that. So this will be pi r, and this will be pi r, right? So together it's 2 pi r. Now, if you think about this as a rectangle, rather than some weird bunch of pieces of pizza that are all lined up in a different shape, okay, think about it as a rectangle. So we're thinking rectangle. The area of a rectangle would be length times height, or width, sorry. Length times width. Well, what's the length here? Pi r, sort of, not exact because these are all these little bumps, but sort of it's pi r, and what's going to be the height there, or the width, is going to be another r, right? So we're doing this guy times this guy, which in the end gives us pi r squared. All right, so like I said, you can Google that and get a much prettier picture, but that's one way of thinking about finding the area of a circle, but using polygons, using what we know from before. So there we go. So the area of the circle is pi r squared. All right. So let's say that the circle they give us looks like this, center, 10 inches. But we only want the area of the shaded region. So we want the area of the shaded region. Okay, now the shaded region looks like it's half of a circle. So can we remember that if we find the whole circle, what do we have to do in the end? We need to cut it in half. Don't. Oh, Handsome wants to say hi to everybody. Hold on 1 second. Come say hi, Handsome. Say hi. Or are you nervous? Oh, now you're all shy. You don't want to say hi? No. Are you enjoying circles? If he's taking in half of what I write on the board, he is one very smart cockatoo. Okay, Handsome, ready to go back on your perch? Okay. There you go, Steven. Okay, sorry about that. So we want the area of the shaded region, which is going to be half of the circle. So we're going to go with the whole circle and then cut our answer in half. Okay, so remember, we need pi r squared. Now, have we been given r? No. So, boop, we don't want the diameter, we want just the radius, which will be 5 inches. Does everybody agree? Okay, 5 inches. Okay, so now if we want the area of the whole circle, the area of the whole circle is going to be pi times 5 squared, or 25 pi. Okay. But we don't want the whole circle, do we? We only want half of it. So the area of half the circle, we're going to take our 25 pi and divide it by 2. Okay, half of the circle divided by 2. Now, as we talked about, mathematically speaking, this is a perfect answer. There's nothing wrong with that. There's no reducing, you just leave it, it's perfect. But if we're in the real world and somebody wants to really know what the area is there, that doesn't help them much. So we get our calculator out, 25 times pi divided by 2, and I get 39.27. And then remember, this is going to be square, in this case, inches. Now again, it's a circle or a half a circle, so there's no way we're going to actually be able to fit a bunch of little squares in there because of the arc going on, which is why the pi is in the problem and why there's a decimal here. But if we could kind of cut and place a whole bunch of little squares, there should be 39.27. All right. So, the last thing that we want to do in this section is look at some kind of weird shapes. Okay, so where do we use area? Okay, area gets used a lot, okay, in your house, all over the place. So if you need to put in new flooring, so put in new carpet or new wood floor, the measurement that you use is area. When you go to the Home Depot or Lowe's, you need to know what the area is of your room. Okay, so let's say that we had kind of a weird shaped room that we wanted to carpet. Okay, so we want to carpet a weird room. Okay, so our weird room looks like this. All right, let's see what we have going on here. So we will say that this is, 20 feet. This is 14 feet. This side can be 15 feet. And this side will be 12 feet. And the radius here is going to be 3 feet. Okay, so like I said, it's a weird shaped room. So the idea is we've got this kind of rectangular room, but it's got this little triangular boop on the side. And then there's this circle. I don't know what the circle is. It's a sinkhole in the middle of your room, or maybe like it's a tree house and there's a big tree coming up through the middle. I don't know, whatever. But you don't want any carpet there, okay? Or you have like a fire pit inside, okay? Like an old 70s house, they have fire pits inside, all right? So you want the shaded area carpeted, but not that. So we need to find the shaded area, but it's not any normal shape that we have, is it? So what we need to do is think about kind of splitting it up into shapes that would make sense. So and different people might see different things when they look at this. To me, when I see this, minus the little circle right now, I see a rectangle and a triangle. Do you see the same thing? And again, there's different ways to go about this. Now, could I find the area of this rectangle? And with a little bit of work, could we find the area of our little triangle over there? And then could we combine them? Okay. So let's go for that. So let's say that we want the area of the rectangle, and that's going to be length times width, right? And we have both of those measurements, don't we? So let's go 20 times 12. Okay. So the area of our rectangle is going to be 240. Now, let's think about this guy a little bit, okay? So we put some labels on this one. We know that this length here is 14. So what's that little dashed red area there going to be? Okay? If this is 20, doesn't this have to be 6? And then along here, we know that this was 12 feet. So what's left over for that guy right there? There would be 3 feet left over. Do you see how I'm coming up with those? So we have to do a little bit of, working things out. Now, you can think about this as a triangle on its side or upside down, whichever way you want to look at it. But if we want the area of the triangle, we're going to go 1/2 base times height, so 6 times 3, whichever way you see it better, okay? And that's going to give us 9. Okay. So together we end up with an area of 249 square feet. But that's the whole area, and what don't we want? This little circle here, we don't need it. So we want to remove it from our area. So what we're going to do is figure out its area. So we're going to go area of the circle, and then we'll take it away. We will subtract it from what we got from the area of the rest of our shape. So the area of the circle, we've got our radius. This is going to be pi times 3 squared, so 9 pi. But we don't want it, do we? So we are going to say that our complete area, so the complete area is going to be our 249 minus this 9 pi square feet. Okay. So again, if you go to the Home Depot and you ask them for 249 minus 9 pi square feet, they're probably going to go, what? Okay, so we definitely will calculate this out. Minus 9 pi equals, so I get that this is approximately 220.73 square feet. So we know what the area is. Now, the real key here though is, do you really think that you're gonna take away that 9 pi square feet, or you're just gonna lay out the whole carpeting and then cut a circle in it? So you probably do want the 249 and just cut a circle in it, but anyway, that's not the point of the problem. The point of the problem was to figure out what the area is there. Okay, so we've got our basic shapes, and then we got some kind of weird ones that they're gonna throw at you, and that's what we're looking at, finding the area. Okie dokie, I'll see you next time.